Okay, so what if a robot could learn a new skill? Not by being shown just once, but by practicing over and over again and actually getting better with every single try, just like a person does? Well, today we're diving into a groundbreaking new system that is making that an actual reality.
And just to give you a taste of what getting better really looks like, the robot we're talking about learned to run an espresso machine continuously for a full 13-hour shift. This isn't some polished lab demo, you know? This is practical, real-world skill.
And it is not just about coffee. This new approach has let a robot tackle all sorts of complex, messy tasks that have been a huge headache for robotics for years. We're talking about folding 11 different types of laundry in a home it's never even seen before, or assembling real packaging boxes right there on a factory floor. I mean, these are jobs that need a level of finesse, adaptation, and precision that has pretty much been out of reach for robots until now.
So why has this been so hard? It's definitely not for a lack of trying. The real problem, the core issue, lies in how we've always tried to teach robots, a method that has a pretty fundamental flaw.
For years, the go-to method was imitation learning, basically learning by copy. A person shows the robot how to do something, and the robot just mimics it. The problem is, the real world is messy, right? The slightest little difference, a cup is at a slightly different angle, a shirt is a different texture, can cause what are called compounding errors. One tiny mistake leads to another and another until the whole thing just fails. The robot can never get better than the single demonstration it saw. But this new model, it's all about learning by doing. The robot practices, it makes its own mistakes, it gets feedback, and it uses all that experience to get faster and way more reliable.
This quote from Robert Heinlein just hits the nail on the head. The whole goal is to build a robot that isn't afraid to try, to mess up, and, this is the most important part, to learn from that failure. So how in the world do you build that kind of fearlessness into a machine?
Well, the solution comes in the form of a new training recipe. It's a method designed specifically to let robots practice and improve all on their own, and it's called ReCap.
Now, I know the full name is a bit of a mouthful, RL with experience and corrections via advantage-conditioned policies, but what ReCap actually does is brilliant. It creates a framework so the robot can learn from a mix of different data sources, moving it way beyond just simple copying and into true self-improvement.
So ReCap basically uses 3 key ingredients. It starts with demonstrations, just like the old way. But then, and this is crucial, it adds autonomous practice, where the robot just tries the task over and over and over. And finally, it brings in human corrections. An expert can step in, not to show the whole task again, but to just fix one specific mistake. This provides a perfect little nugget of data on how to recover from that exact error.
So here's the million-dollar question. How does the robot know if its own practice is going well or, terribly? It needs some kind of intuition. And this is where ReCap's secret weapon comes into play.
It's a system called a value function. You can think of it as the robot's internal critic, or maybe its gut feeling. At every single moment, this value function is predicting the probability of success. It's basically asking itself, based on what I'm doing right now, am I on the right track to actually finish this task?
And this internal critic is the engine that drives this incredibly powerful learning loop, turning all that raw practice into genuine skill. So let's break down exactly how this whole process works. This brings us right to the key question, doesn't it? When the robot is off practicing by itself and there's no human around to help it, how does it even recognize that it's made a mistake?
And the answer is that internal critic. The moment the value function sees the probability of success suddenly drop, it raises a red flag. It tells the system, hey, that thing you just did, it seriously lowered our chances of succeeding. That feedback is the exact signal the robot needs to learn not to make that same move again.
And this just lays out the whole cycle perfectly. So let's walk through it. First, the robot practices the task all by itself. Second, it gets feedback. That could be a simple success or fail at the end, or a quick correction from a human. Third, all of this new data is used to update the value function, making its gut feeling even smarter. And finally, the robot's core skill, its policy, is refined based on that improved critic. Then the whole loop starts all over again. And with each cycle, the robot gets better and better and better.
Now, this isn't just some small improvement on paper. This cycle of practice and refinement leads to some dramatic, measurable boosts in real-world performance. The results really show a massive leap forward in what robots are capable of. Look at this.
What's really wild here is the change in throughput, basically how many espressos the robot can successfully make in an hour. It went from about 10 drinks an hour to over 20. So it didn't just get more successful, it got way, way faster. And that's a huge deal for any kind of real-world job.
Yeah, this isn't just a tiny little tweak. On the toughest tasks, like making all those different coffees or folding all that laundry, the recap method more than doubled the robot's speed and efficiency. Doubled!
And it's not only about speed. Check out the failure rate. Before recap, some of these really complex jobs would fail about half the time. After recap, that failure rate was cut in half. The robot becomes so much more reliable, which is absolutely critical if you want to use it for anything where you need consistency.
So here's the big takeaway. We are really seeing a fundamental shift here, from robots that can only follow a pre-written script to robots that can genuinely learn from their own experience. This is a clear roadmap to building machines that improve, adapt, and actually master their skills out in the real world.
And that leaves us with a pretty fun thought. As this tech keeps getting better, it just opens up a whole world of possibilities. So if you could give a robot like this just one chore to practice and perfect in your own house, which one would you give it first? Something to think about. Thanks for tuning in.